Hi guys, it's Cooperation Week. Today we will be looking at cooperative problem solving in a social carnivore. So, why study cooperation? Well, studying cooperation in animals is important because it gives insight into the cognitive abilities and cooperative behaviors of our own species. In the experimental context, cooperation entails that at least two animals perform similar or combined acts in pursuit of a common goal while also taking into account each other's behavior. Experimenters organize cooperative behavior into 4 levels, ranging from least to most difficult. The least difficult is merely similarity between acts. Then synchrony, similar acts performed in unison. Then coordination, similar acts performed at the same time in the same place. And then most difficult, collaboration, complementary acts performed at the same time and the same place. This paper presents the first experimental evidence of cooperation of a social carnivore, the spotted hyena. Researchers have previously focused solely on primates' cooperative behavior, but it has been found that they are often ineffective at solving cooperation tasks in the lab. This could be explained by the fact that they forage individually in the wild. However, a species such as the hyena, which cooperates with conspecifics more frequently in the wild, serves as a much better candidate for testing cooperation in a laboratory setting. Because hyenas are biologically predisposed to cooperate, it is expected that they will fulfill the lab requirements of cooperation, especially that partners will attend to each other's actions, and that coordination of behavior between partners will improve with experience. All 3 experiments had the basic task that involved the delivery of hidden food rewards contingent upon a hyena pulling on a suspended rope, which would release a spring mechanism and cause a trapdoor to swing downwards, dropping food onto the floor. This was the solo task. The cooperation task involved an additional spring mechanism controlled by a second rope. Thus, the only way to obtain the food demanded that the hyenas work together by pulling in unison to release the trapdoor at the same time. Duplication of the apparatus increased the challenge of the task. Its success then required both temporal and spatial coordination to work successfully at the same platform. Cooperation was thus studied at 2 levels of complexity. Synchrony involved 1 platform, and coordination involved 2 platforms. The following images show the differences between tasks. The top image shows the solo task, in which only 1 rope needs to be pulled. The bottom left image shows the synchrony task, in which 2 ropes need to be pulled in unison. And the bottom right image shows the coordination task, in which 2 proximal ropes out of 4 available ropes need to be pulled in unison to release the food reward. This image shows the synchrony cooperation task. Experiment 1 examined whether the hyenas could solve the solo task followed by the cooperation task. Subjects included 3 adolescent members of an all-male social group. Animals hunt at the age 11 to 22 months as well as have defined stable dominance relations at this point. Hyenas were ranked according to dominance relations, with subject C as most dominant, P next, and H as the least dominant. All tasks involved 1 or 2 elevated platforms, each with either 1 or 2 ropes hanging from it connected to a spring release mechanism controlling a trap door. Food rewards that were not visible to the hyenas were 2 bone chips and 2 meatballs on each trap door. The subjects were habituated for 1 month to platforms because hyenas are known to be neophobic. The same general protocol was followed in all experiments. Hyenas were first tested on the solo task, then the cooperation task with different levels of complexity, synchrony and coordination, and different social contexts, pair versus group. Hyenas were presented as a group of 3 for the solo task in 70 total trials, and then tested alone with 70 trials each, to fully habituate animals to the task in different contexts. Only 1 hyena pulling was needed to open the door for the solo task. Subjects were partnered as CP, CH, and PH first for the coordination task in 3 trials each pair. They were then tested for the synchrony task in 14 trials each. The most complex condition occurred first to assess ability independent of shaping. Then the simpler condition followed to provide info on performance at a level of cooperative complexity similar to that of primate studies. Researchers measured success by the percentage of trials that a trapdoor was opened to deliver food. Efficiency was measured by the latency in minutes to open the trapdoor. Hyenas solved the solo task with 100% success regardless of social context. Despite the complexity, pairs were 100% successful with coordination trials and showed remarkable efficiency even on the first trial, with the lowest latency being 0.27 minutes. Success remained at 100% for synchrony trials, and there was even better average efficiency. Thus, after plenty experience solving this solo task, partnered hyenas spontaneously displayed cooperative behavior both at the level of synchrony and at the level of coordination. Experiment 2 looked at social modulation, how cooperative performance is modulated, facilitated, or inhibited by social context, rather than how animals learn to cooperate. Subjects included twin females, N and I, and twin males, G and V, again ranked by dominance. Materials were the same as in Experiment 1. Testing procedure varied from Experiment 1, however, as researchers developed a baseline of solo performance with only 10 trials for each hyena. They then established a baseline of performance for each level of cooperation by presenting each dyad partnered as follows, with a single coordination trial and a single synchrony trial. They continued testing with all 4 animals present in 10 group synchrony trials, followed by 10 group coordination trials. After the group experience and to test for rank effects, 10 pair synchrony trials and 10 pair coordination trials were carried out for each dyad. Data collection was also more complex than in Experiment 1. While success and efficiency were scored, researchers also scored behavior directed by the animals to the apparatus to calculate measures of coordinated action, the percentage of responses allocated to the apparatus when a partner was present or absent. They also scored all behavior directed by animals towards the other hyenas. Despite success in the 10 baseline solo trials, results showed that all 6 pairs showed 0% success in the single baseline trials of pair coordination, as indicated in Figure B, and pair synchrony, indicated in Figure C, likely because of the fewer trials on the solo task. When cooperation testing continued in a group setting, however, pairwise performance dramatically improved, with 100% success for both the group synchrony trials seen in Figure D and group coordination trials seen in Figure E. Every possible pair opened at least one door. This indicates that the addition of animals enhanced performance. After the group trials, pairs continued to maintain a high standard of success in the pair synchrony trials as seen in Figure F, and pair coordination trials seen in Figure G, indicating that group exposure to the task enhanced performance, as did the prolonged exposure in Experiment 1. Differences because of social modulation were present. Social context affected the efficiency in that pairs showed decreased efficiency in synchrony trials after the removal of other members. Efficiency of pairs also varied across partnerships, as dyads with dominant members were less efficient and successful, but dyads with lower ranking animals were more efficient and successful. This was correlated with aggression. Thus, performance was facilitated by greater number of animals present, but inhibited by aggressive dominance relation between partners. These graphs show latency and success by rank relations. The top 2 graphs show latency on the synchrony and coordination tasks, while the bottom 2 graphs show latency and percent success on the synchrony and coordination tasks. Success is indicated by the black dot, whereas latency is indicated by the bars. Here, you can see that the pairs with more dominant members had higher average latencies and lower success rates in comparison to the less dominant members on both synchrony and coordination tasks. Experiment 3 was conducted to further analyze whether hyenas take into account each other's behaviors by examining the effects of cooperative performance with a naive partner. Subjects were all 5 members of Cohort B, including the singleton male W, who is cooperation naive. After reaching criterion on the solo task, Subject W was paired with each of the experienced cooperators of Experiment 2, creating the new partnerships as follows. Each dyad was presented with the coordination task in 10 trials. Researchers aimed to examine the behavior of hyenas paired with Subject W, so they created an additional measure of coordinated action defined by following or joining the partner at the apparatus. The results of this experiment found that 3 out of the 4 pairs were successful on Trial 1 and moderately efficient. Cooperation was facilitated by the experienced partner by monitoring the naive one and adjusting its own behavior to ensure proximity. Experienced hyenas accommodated their subordinate partners in experience by assuming follower positions and joining the naive hyena at whichever platform he had approached. This pattern reversed in later trials, however, when the formerly naive animal preferentially joined his higher-ranking partners, indicating, again, that rank affects performance. Spotted hyenas proved to be exceptionally skilled cooperators, as all hyena pairs efficiently and successfully solved tasks that required a sophisticated level of organizational, cooperative complexity. Repetition and social facilitation are important factors in the acquisition of cooperative behavior. Additionally, hyenas are sensitive to their social circumstances and partnerships. This is proved as they modified their behavior according to group size, rank relations between teammates, and partner expertise. Cooperative behavior is shaped by learning experiences and social circumstance. This suggests social complexity is a driver for the evolution of intelligence. Hyenas' abilities provide a comparative framework for testing theories about the mechanisms of social learning and the evolution of intelligence.